into it. I'm going to talk about monorepos today, which I'm excited has gotten more awareness lately in the JavaScript community in particular. And we actually, at my company Nrwl, we have a resource called monorepo.tools. I'd encourage you to check that out because we actually work on that with people from other teams, other companies who work on monorepo tools, monorepo tooling, to make it as an objective of a resource as possible about why monorepos, the philosophies, other approaches, and the tools you can use to work with monorepos. And I'm going to talk today about what monorepos are, kind of how we got here, and how you might think about using them. So again, shameless plug for this site. And unfortunately, I didn't remember to include pig pics in this presentation. So if you like pigs, follow my Twitter @JeffBCross. I just tweeted a picture of my favorite pig, Cheddar. And Kuni pigs are really cool. They're really hairy, really round and chubby and adorable, and they love to cuddle. So that's my favorite thing. So I'm going to talk a little bit about history and kind of the undulation of different ways that teams have organized code over the past 17-ish years, from 2005 to 2022, which I break into these three steps from monolithic trunks to polyrepos to now more of a move to structured monorepos. So way back in 2005, most development was trunk-based development, or trunk development, where an organization would have one trunk that has all related software in a single code repository. Anything that was shared or used, you would have many distinct projects, and they would be in a single trunk. A lot of times managed with SVN was kind of the dominant one. Has anyone used SVN here? I'm just seeing how old the crowd is. Yeah, so SVN was great. It was, I mean, there are other version control systems, there still are. SVN is still used, there are other ones still in use. That was the dominant player then. And in those cases, SVN, it didn't do a lot to, it really was just about version control. It didn't do much to help you structure your repository or to organize things in a certain way. It was most teams used it in a very centralized way, and even when you're committing directly to some central source, and you're pulling from that. So it's a lot different from how software is developed today. But by the way software was developed, because it was these large trunks with many related projects in a single code base, there were some problems that teams struggled with. Like the boundaries between code inside those repositories was not very well managed. You kind of came up with a folder structure, and there was some tribal knowledge of who owned what, and that was about all you had. And as the repositories grew, if you added any kind of continuous automation, continuous integration, your tests and builds would get slower as the code base grew. And lack of ownership of different parts leads to dysfunctional teams who kind of do things in different ways in the repository. There's no consistency, there's poor communication, and that is kind of the impetus for why teams started to do things differently. But there are actually three things that happened in the space that also accelerated a different way of developing software. The first one was the rising popularity of continuous integration. So having automation in your environment so that you're not doing tests locally. Testing was also growing in popularity. Like I worked on lots of code bases in 2005 that had 0 tests. And still I see some code bases that have 0 tests. But now it's more common, it's more expected that there should be some kind of automated tests in your code base. And, but as more automation was added, the time to validate a change before merging or after merging grew, so that if you have a large team, then you've got a backlog of people waiting on CI to finish. And as the code base grew, as the team grew, these problems grew with it. The second thing that happened was Git and GitHub. So Git introduced a more lightweight way to manage version control or source code control, where you don't have to commit remotely every time. You can do local forks, local branches, do your commits, clean up things, then push them, integrate. Lots more powerful ways of rebasing and interacting. And along with that, GitHub was developed. So there's this new way of managing source code and a service to go with it that makes it easy to create many repositories, many lightweight repositories easily. And the third thing that happened, particularly in the JavaScript community, and outside of JavaScript community, package managers have also gotten more popular, but NPM and semver. So having a first-class package manager that was originally just Node, but then became the standard for the web as well. Having that to where you could have many repos and publish them to their own packages, and there was a versioning scheme to where you could You could actually publish these and version them and say, okay, I can set my constraints to say depend on stable versions, depend on, like I can do patch updates without needing to explicitly update it. So these things made it where it became a lot easier for teams to separate their repositories out into separate repositories. And I call this polyrepos. I have a Greek friend who I talk about the nuance of if polyrepos is the right term or what, but just for the sake of monorepo versus polyrepo, I call this kind of way of organizing your code into many repositories polyrepos. So those things led to that big shift in polyrepos to where instead of having a single trunk that has a bunch of somewhat loosely defined pieces of a project together, we would have these more concretely defined repositories that had relationships based on dependencies. And it could look something like this. But another thing that changed in addition to, and this was nice, so it enabled more team autonomy. A team has a repository, they tend to stick with that repository, they know everything that's going on there, they can set up their own testing, their own CI, their own docs, their own publishing, whatever they want, they can do it there. But it came at some costs. So one of them was that in reality, instead of where originally with trunk-based development, or if we just had polyrepos where you would be depending on source of your code and be depending on head all the time and have somewhat evergreen repositories, now repositories depend on version snapshots of other code. And because of that, you would have late integration of changes. So an app that's depending on a shared library is going to integrate those changes when the app decides to, which could be 6 months from the time a change was made. And which leads to problems of like you don't validate changes as quickly, you are less likely to make changes in that shared repository if you're on that app team because you know it might be 6 months before you get that change if your tech lead isn't going to update it. So it leads to this late integration. And there's also a high setup overhead per repo. So the autonomy is great, but you have to set up your own CI, you have to set up your own publishing, you have to set up your own documentation. And if you've got an organization that wants consistency, then you have to follow some standards to do this across different teams. And it's also difficult for developers to contribute outside of the repo, and because you don't know the tooling of the other repository unless there is some strict standard. And the overall complexity increases because of versioning. So because you have shared libraries that can publish at different versions, and you may have a transitive dependency that depends on different versions of that library, you have to figure out how to avoid issues that can come with having two transitive dependencies of two different versions of a package, which leads teams to creating fewer of these shared libraries to avoid that complexity. So you have still a bunch of small monoliths. Oops. Went the wrong direction. So some of the outcomes of this were that you have significant duplication of code. Because there's overhead to creating shared repositories, overhead to contributing to other repositories, and effort to integrate from other repositories, teams tend to just write the code again. If you have a common component, you might just say, okay, I've got to meet deadlines, I'm going to write this button here, I'm going to write this form, I'm going to write this service in this repository that I need, and other teams are going to write this 10 other times. And whenever that service changes, all 10 of those teams need to update 10 places. It also introduces inconsistency of UI across teams because every time it's implemented a little bit differently, even if there's a good design spec. And naturally, teams become more siloed if they're operating most of the time in a repository that's cut off from everyone else. So recently, because of this, we've seen a few things have happened to shift back to looking at monorepos, or like, so monorepos is a keyword. I would say, to put it a different way, more structured repositories. So consolidating more work in more structured repositories. So teams are wanting more cross-collaboration across teams. More like, let's do this component once. Let's do these services one place. So we have to maintain it one place, we create it in one place, and we've got the consistency that our customers can enjoy. And product owners want the more consistency, so the users are getting the same experience even if they're going across orgs. And the thing that we've been involved with is tooling to enable monorepo use cases to be more pleasant, to address some of the things that drove people away from these trunk-based development so long ago. And so I've mentioned a couple other tools here just because it's more about monorepos than about NX, but we have this tool called NX that we've built over the past 5 years. as we've worked with clients who are wanting to do these things I've talked about, who've wanted to move more towards structured repositories. We didn't set out to make a monorepo tool, but I came from Google, which has a big monorepo. And when we left Google and saw how people were developing software and wanted these things, my partner Victor and I, we said, okay, like we need to make something where we can enable these teams to have better workflows around monorepos, and that's how NX came about. There are some other great tools. Lorna, we actually just took over stewardship of, which has been another big tool in the JavaScript space for a different kind of philosophy of monorepos. It still kind of has this polyrepo mindset of several packages, but you can co-locate them together and actually Learn and NX collaborate or work together pretty well. And there's another new entrant, turborepo, that's focused on performance optimizations like caching. And Bazel is Google's tool that's very mature. It's also a lot of, we love Bazel. NX is actually inspired heavily by Bazel. But it's a lot. It requires a lot of knowledge to set it up properly, but it is very powerful and very mature, especially for Java, C++, Python, anything that Google develops with. There's great support for in Bazel. NX, so in particular, we solve these challenges that you need to solve if you're going to move more teams and more code into a same repository. It needs to be fast, so we have things in NX that inside your repository, one of the things that drove people from trunk-based development to polyrepos is test and automation timing. We have, with Bazel, NX, and a couple of other monorepo tools, now you can have your projects organized and have clear boundaries, clear encapsulation of projects within a monorepo. And tools can actually see when you make a change. It can compare a delta between two commits and see what you've actually touched and what can transitively be broken by that based on the dependency relationships inside your monorepo. So you can only build one project if you need to, build the whole repository if you need to, or build just a subset of your dependency graph. We do things also distributing work across different agents intelligently, computation caching, but also things like having more structure and more boundaries between projects to impose constraints to say, I want to be able to create a project that someone else can't depend on unless I want them to, so that I'm not having to support a public API that I didn't want to. I can still have this autonomy of my team to experiment and to do things in isolation, but easily contribute across other pieces of my code base. I'm going to go through a couple of examples to show kind of what that looks like in practice. And again, this is not tool specific to NX, but is about monorepos in general and how the experience changes. So let's say we have a design language. So Nrwl, we've defined a design language. It's got blue in it because we're ocean themed, of course. And we've got this button. It's got a border. If we had two repositories and two teams who've decided to implement this themselves, you may end up with something like this. And buttons are a little bit easier to get right, but with any design system, if it's specified but implemented in many places, you inevitably end up with this kind of UX inconsistency. And why is that? Because they live in their own repository, the design spec left some room for interpretation. It would take too much work to create a common button repository. Maybe no one's championed setting up a design system team with its own repository or all the organizational overhead to do that. I'd have to do all these things to set up a separate library. And then there's an awkward life cycle of me making this change in the design system and then incorporating it into my app. It's a lot easier. I've got deadlines to meet. I've got pressure from product. I'm just going to do it in my own repository and end up with my own button. So it's just an example of, with polyrepos, it's easier to do the wrong thing. There's more organizational pressure to do the wrong thing in terms of maintainability. But if the team had a monorepo, it might have something like this where they have multiple apps. All they have to do is create a separate project in their monorepo called common components, or even a project for the button itself. And it uses the same CI. There's an obvious place for it to go. And when the button needs to change, I just agree with someone else on how it needs to change. And that's what I call a good tension, that you want some things to have some friction. You want to be forced to be thoughtful about things instead of having too much independence. Sorry, this slide got moved out of place. Let's look at another example. So, and if anyone uses Angular, you'll know these versions are pretty old from this graphic. But let's say we have two separate apps with who depend on separate versions of Angular. So they're built in isolation. They depend on just slightly different versions of Angular. But when we have a common library that is is bound to a specific version of Angular, it can't work with the homepage app, but it can work with the customer's app if it's on the same version. Now, in some cases, actually, you can have multiple versions of a library bundled, but in framework cases and a lot of library cases, there are instance of checks that if you have one component from one version of Angular passed to another version of Angular, it's not going to recognize it as an Angular component. And that's in addition to the performance downsides of having a larger bundle. So this is an issue. So again, polyrepos make it easy to do the wrong thing. One philosophy of a monorepo that makes life a lot simpler is a single version policy. And so what this is inside of a repository, all of your first-party code depends on source of the other code, but you also agree on third-party versions of code that everyone in the repository will standardize on. And it takes some work to say, okay, we're going to be on the same version of Bootstrap or the same version of Lodash or whatever date functions, Moment.js, whatever libraries you're using. To do that and to upgrade it does take some coordination, but you're basically paying up front for something you would have deferred the payment for and paid interest on if you were doing it in a more distributed environment where you had several repositories where you had to update this in many places, wait to integrate your shared dependencies later. So it's all about trade-offs, and I think the trade-offs tend to err in favor of a single version policy because of how easy it makes it to collaborate across teams and guarantee compatibility about everything in your domain. And let's look at a third example of fixing a bug in a shared library compared with a polyrepo and a monorepo. So let's say somebody's reported a bug in our homepage and we figured out the bug lies in our common component library. So the workflow would look something like this in a polyrepo. I write some kind of test to confirm the bug, I fix it, test pass, merge it, tag it. A week later, someone in the homepage app sees that I bumped the version and they update it, and the tests fail. Like we write our own integration tests and see that they didn't actually fix the test. And so this is because the test could pass locally without actually verifying it in the integration, in the app itself. Because we don't live in the same repository, and it's kind of cumbersome for me as someone who works on the common UI to set up to be able to test within the app if I don't know that repository well. So by the time the app has realized that they didn't actually fix it, it's already been tag released. The developer's probably gone home for the weekend and they've forgotten all about the change. They've lost all the context. It requires a lot more work for them to fix the issue then than it would have if they would have caught it early on. So if we look at the same scenario, but both projects exist in the same repository, we have a flatter workflow like this. The homepage test creates its own integration test in its project. The common component maintainer will create their own end-to-end test to verify the behavior. They see the test fail right away before they don't even need to update the PR. They can run the test, see that the regression test fails. They fix it immediately. Test pass, they merge it, no publishing required. You could tag it and release the app if you want to, but it's fixed. Everyone can go home for the weekend and you know everything works together. So because they're in the same repository, you spot the regression earlier when it's cheapest to fix. And that's all. I hope I gave a little bit of how the experience can be better with monorepos. I'd encourage you to check out this website that myself and a couple others from Nrwl and from other companies worked on putting together to talk about why monorepos can make life better for a lot of teams, and also the tools that you can use to make monorepos more pleasant. And that's all I got. Thank you.